Hey guys, I just wanted to review vector basics a little bit with you, and I made this kind of cheat sheet that covers all the key points that you will need to know about initial vectors. Okay, so here I have a vector stretching from the origin of my graph here to this point xy. Okay, so the vector A is given by the black line that you see here. Okay, so that black arrow there is vector A. And remember that a vector has two key properties. It has angle, which in this case is given by angle theta, and it also has magnitude. In other words, the distance from the origin to that point x, y. Note that x lines AX and AY here form a right triangle. So we can find that magnitude using the Pythagorean theorem. All right, so let's talk about what we can do if x and y are known. First thing we can do is we can easily find that angle theta if we know x and y. Okay, so tangent of theta is going to be equal to the y value of vector A divided by the x value of vector A. So we can find the angle using the arctangent function in your calculator, and you'll just input that value a sub y divided by a sub x. To find the magnitude of A, in other words, the distance from the origin to that point x sub y, we will just use the Pythagorean theorem. So the magnitude of A is equal to the square root of the quantity a sub x squared plus a sub y squared. And as I stated earlier, magnitude is a scalar, or maybe I did not. Scalar quantities do not have a direction, that's all. So one example of a scalar is speed. And there are lots of others. Mass is a scalar, etc., etc. Okay, vector properties of A are summarized here, where vector A is equal to the vector a sub x plus a sub y. And I have drawn a sub x and a sub y here in red and blue. So they are vectors themselves. A sub x does not have a vertical component though. A sub y does not have a horizontal component. Note that one interesting thing we can do is rotate a vector so that it will actually have horizontal and vertical components. So if you define your coordinate plane, you can simplify things or make them more complicated. Depends. So we'll cover that a little bit more later, perhaps, as a useful analysis technique, not techniques. Okay, so vector A is equal to the addition of vector a sub x plus a sub y. What we then know is that vector A will be equal to a cosine of theta plus a sine of theta. Okay, so this A here is just the magnitude of vector A. So maybe I should make that a little more explicit. Yeah, something like this. Okay, so if you know the magnitude of A, you can find the vector itself. Okay, if you know both x, if you don't know x and y, but you do know the angle, and you know the magnitude of A, then you can find both x and y fairly easily. So a sub x, the x value of vector A, is equal to the magnitude of A times cosine of theta. And from this we can find our angle as well. Okay, so that's very useful. You can't always use the tangent function to find a vector, so this can be a quick shortcut. So in other words, if you know the magnitude of vector A and you know the horizontal value of vector A, then you can find the angle without worrying about vector, the vertical value. Okay, likewise, if you look at the vertical value and you know the magnitude of the vector, then you can find the angle using the inverse sine function. Okay, so that is a brief explanation of vector basics. This should be a review, I think, in theory. And what I recommend that you do now is go do some practice problems in topic 1.3. And you can do that either in your textbook or in Cognitive. Okay, so that does it. Have a great day, guys. Take care.